Hopefully you can still see me and hear me. Um, my name is Guillermo. I'm an engineering manager in the Splash Office team, and I worked on this presentation with Viktor, who is an engineering manager in the storage team, also in Adevinta central teams. And we're going to talk about DevOps in Adevinta and in general. Okay. So we've divided the talk in three parts. Okay. And the first one is a little bit of old man storytelling. We want to tell you a little bit about what software engineering felt like 15 years ago. So I'm feeling very old lately because I think I'm probably one of the oldest millennials. I just turned 40 this year. And so this is what all people do. They tell stories. So here it goes. Okay. So I'm going to tell you, then Viktor will tell you some anecdotes too, but I'm going to tell you what it felt like to be my first software engineering job around 15 years ago, a little bit more, but yeah. So when I first got into the job, I met my manager and the people in my team, and I was, of course, as everybody is in their first job or in the first day on any job, for that matter, I was excited and nervous. Okay, and also I had a sense of, oh, will I be good enough? I haven't programmed professionally ever, right? So when I got into the office and I was introduced to the project and everything, I was asked to write a piece of software. And I was given some instructions and I was shown around the code and I started programming. And I spent a few weeks like this. And it felt just like you see in the photo, it felt great. Okay. I was super concentrated and I was making a lot of progress. I felt like I was doing a fantastic job. And it felt like I had gotten up to speed very, very fast. I was doing what the manager had asked me to write. And it felt like I was on a great start, right? So it felt super empowering, right? And then when I was done with the first task, a couple of weeks later, maybe, I told my manager, and then so he told me, "Oh, this is great. Now you're going to meet our quality assurance team. They're going to test the software that you wrote." And I was, okay, that's great. Let's do this. And I gave them the software, probably in a USB stick or even a CD, something like that. Okay, now physical media. And then something started that sort of felt like a ping pong match. Okay, I gave the quality assurance team the software. I said, here it is, guys. You can test it. And the first thing that they told me is, hey, the software won't even start. We can't even run it. I was like, oh my God, this was a kind of embarrassing, right? So I went over and I looked at what was happening, and I immediately saw what was going on, and I said, okay, don't worry, I will fix it very quick. I went back to my computer. I fixed it. I rebuilt the software, copied it to the USB stick again, and ran over to the desk of the quality assurance team and gave it back to them. And then they started testing again. And now they could start the software. But, well, now it was very quickly crashing. And I was like, how can that be? I've been running the software and it wasn't crashing. And I went over and I asked them, can I see what how you're using the software? Okay. And they told me, yes, come over tomorrow. We have some time and you can come over and look at that. And I went over and I looked at how they were using the software. And immediately I saw that they were doing things I hadn't anticipated, right? And I said, oh, now I see what's happening and I know what's wrong and I will fix it real quick again. And I went back to my laptop, well, not a laptop. I went back to my computer and did the same thing, fixed the bug, built the software again, and gave them another USB stick with a new version of the software. Okay, and now they went back to testing again, and I said thank you, but look, 5 minutes later or 2 hours later, Guillermo, this is crashing again. We can't test it anymore. And this was very embarrassing. It's like a ping pong match. I'm sending the software and they're returning it because it doesn't work. And at some point, I was looking at them use the software, but I couldn't figure out why it was breaking for them. So I was like, "Will you let me run a debugger in your machine?" So I had to go over, and they said the same thing. Sure, of course. Come over tomorrow and we can do that. So I sat with them, and this was over and over until the software was working, more or less. Okay, and I'm sure you've heard people say this in the past. So the software works on my machine, but then when I put it outside, it doesn't really work. There are lots of memes in the internet around this. Okay, so perhaps your machine is the only one where it works, and it really feels very frustrating, because every time that somebody comes back to you and tells you that they can't run the software that you wrote, it feels like a failure. It feels like also you're not in control. That the work should be different, right? It should be more predictable, smoother, right? So it was a constant sense of frustration, embarrassment. Okay. Now, when the software was tested, now, Guillermo, you have to meet the sysadmin. System administrator will run your software in production. It will start being used by our customers, okay? And guess what? A few days later, the software breaks, even if the quality assurance system had tested. But now, this time, it's a fire because it's actual customers that are suffering the problem, and the system administrators have to mitigate the problem. And Viktor has a background as a system administrator, so he's going to tell you what this felt like from his point of view a few years ago. Viktor?
Yeah. Hi, everybody. As Guillermo said, I started my career as a system administrator. So I'm coming from a different background than Guillermo. And I brought you 3 stories that I hope they will be funny, because for me, they are funny 15 years later, right? But back then it was a very pressuring time. Let's put it that way. Okay, so here it goes. This is from 15 years ago when I was finishing high school. I already had an interest in IT. I had some practice as well because I was helping some local internet cafes. I don't even know if these things are still exist, but like a local internet cafe to build the networks. But basically, after I graduated from high school, I applied for a job as a PHP developer. But well, a couple of days later, I was the system administrator because apparently to be a developer, you need to have coding skills, which I did not really have. So I chose to be the sysadmin in the end. And it started to work out because I already like servers, right? Next, please. Yeah. So basically, a couple of days later, I got root or administrator access to their servers, and they asked me to remove an old website from one of the servers, right? So I typed in the command, which is more or less this, but I made a mistake. I don't know if you can spot the mistake, but basically there's a space between inside the command, right? So what this did, this removed this etc directory, which stores all the configuration files in Unix-based systems for the server, right? So what happened is that the whole company went down for for a couple of hours. They were not very happy with my performance, to be fair, because this was on my 3rd day and I was very, very young back in the day. However, they didn't fire me because 15 years ago, this was the reality of being a sysadmin or doing system administrator work, right? We didn't have documentation. They didn't have, next please, no documentation, no process. The servers had too many moving parts, right? Because everything was configured by hand. Fragile configuration, same thing, everything configured by hand. Lack of automation, we didn't have any automation in place, everything was done by hand again. And a lack of infrastructure testing, we did not have any tests. So whatever I did, it was on the production servers and it might have failed. So this is one of the, no worries, this is one of the stories. An interesting one when I broke the company after 3 days after joining. Yeah. The second story is about a time when we had a lot of headaches. We were organizing huge LAN parties for Counter-Strike and Call of Duty with friends in 2010. This was like 350 people in basketball courts with their CRT monitors. Well, I mean, I included a photo from one of the events, right? This was in Hungary, so this was quite a big deal, especially for me. At this time, I thought I knew everything about networks and computers. I was 19, so this was obvious that I knew everything, right? So for our next event, we ordered this multi-socket motherboard, which means that you can install multiple CPUs to the same motherboard. I included another photo, which I'm not very proud of, but I was still 19 at the time, and I was super happy with this multi-socket motherboard. You can see the two white sockets for the CPUs. And I'd like to point out the fancy IBM hat in the background, right? I was a huge fan. No. So as I said, we ordered this motherboard, and they arrived with the CPUs, and they didn't work. Next, please. I think we had enough of my young face. So everything arrived, we put it together, and it didn't work. And it turned out that the CPUs were not compatible with the motherboard. So basically, this was not a very good point because we had only like 1 day before this like event, and we didn't have a working server to have internet in the location. So we had to borrow one CPU from a friend, and that saved us in the end. Another failure from my early days, right? So basically, the conclusion is that we managed to make it work, right? But mistakes were made again. We had too much confidence. Depends where you look from. However, we didn't have a lot of confident people, right? Competent people who worked with servers. We didn't have a lot of testing before. We didn't have documentation, and we didn't have a process on how to manage these things. So all in all, it's very similar to the previous failure I discussed, but from a different perspective, right? So basically, the third story, and maybe my biggest mistake in my career, is that when I was working as a systems engineer in research and development department in this adult entertainment company, basically they had a lot of physical machines, servers. Cloud was not a thing back at those days, and we were hosting live videos, right, or sharing live videos. I had a mentor who actually hired me, a very good friend of mine, and we were do this pair systems engineering, which is a term that I invented when I was writing this presentation. It's very similar to pair programming, right? But the idea is that you work together with other people, and then you do infrastructure together. So this is the idea. One day he was out, so I started the routine maintenance and removed a component which brought down the whole site. We didn't understand what happened, but it turned out the developers started to use the testing environment as production. And when I started this routine maintenance, actually the site went down because it was production. They didn't inform us, so when I came with the hammer to do some maintenance, the site went down. This was not good, but apparently we were able to fix it fairly quickly. Next, please. And then the next slide. The mistakes are very similar again, right? Or the conclusions that we were able to do is that the lack of communication, lack of synergy between teams, lack of documentation, and a lack of process caused all these issues. There was a lot of ping pong all the time between different teams, like the sysadmins and the developers and the QA teams and the QA teams and the sysadmins, right? This caused frustration for everybody. So basically, this was not a a way of working that everybody wanted to keep out. Everybody felt miserable because in a classical tech organization, there were three different teams working together in theory: software engineers, QA engineers, and system administrators or system operators, right? Software engineers felt they felt their work was improvised and did not feel like engineering. They were continuously embarrassed by the fact that the code they wrote was not running on other machines. They were disliked by QA for delivering buggy software, right? And they were disliked by system administrators for delivering hard to troubleshoot software. QA engineers received buggy software, which was hard to test. They were pressured to accept this buggy code to speed up testing because the software had to be ready, right? And they felt embarrassed when this tested code did not work in production in the end, or it failed. And system administrators were frustrated or miserable because they had to wake up at night for other people's softwares. Yeah. They had to troubleshoot software written by others, which is very, very hard to do. And they had to maintain the infrastructure manually without any code, and mistakes were fatal because there was no testing. So we attached a photo of a typical tech organization from 2005. It was more or like this. Everybody was fighting with each other to make it work, but it did not work out in the end. So the terminology DevOps was created.
All right, thank you, Viktor. So we're moving on to part 2 of the presentation, where we're gonna talk a little bit about what is DevOps and what is a DevOps engineer. Okay, how have things evolved over the past 15 years to make things better for the people involved in the software development and delivery process. Okay, so what is DevOps? Basically, we were talking about 3 roles, 3 different teams of people with very clear different responsibilities, more or less fighting each other because they were not under control of the problems that they had. Okay, so DevOps is basically a set of practices that have made it possible for teams to own their software end to end. So the same engineer that's why they have 3 pairs of arms in the photo, right? The same engineer today writes her software. She tests her software and she operates her software. So she's responsible for the 3 stages and the 3 responsibilities. And that means that basically she has control over everything that was frustrating the 3 types of engineers 15 years ago. And that control allows teams today that follow DevOps practices to not feel miserable as many engineers were feeling 15 years ago. Okay, so what are these DevOps practices that I'm speaking of that have changed more or less how software is delivered versus how it was done in the past? So the first one is agile development, which has evolved since, I think it's pretty much 15 years, right? Basically, it's a huge and fascinating topic, but if you can summarize it in one sentence, it would be that you deliver software in very frequent but very small increments, okay? Which is key for the rest of things that compose the DevOps practices. The second is that the second practice is that you do continuous testing, okay? So tests are not done after you deliver the entire piece of software, but as you write code, you also write tests for that code that will be run automatically for you and will be run after you make each change, okay? And you know how much of the code you have tested because you can measure that as part of your continuous testing strategy, right? The third one is continuous integration and deployment. Okay, so every time an engineer today puts a piece of code in the code base, it gets built, it was compiled, the tests are run, and if they pass, they get deployed. Sometimes to a development environment, but ideally, the more mature teams put them directly in production, right? So, which mean which the, what it means is that because you're doing agile development, the rate of the size of each change that you deliver is very, very small. When there is a problem, it's very, very easy to pinpoint and which change introduced the problem, right? So it's much easier to troubleshoot software. Nevertheless, sometimes things don't fail immediately after the deployment, right? So you need to monitor how your system is performing in production. So another one of these practices is that you continuously monitor the software that you have developed, and because you are operating it, you wrote it and you operate it, you make sure that the software that you're putting in production is instrumented so it can be monitored and you can actually observe how it's behaving in production. And the last one is that infrastructure today is defined as code. It's no longer, you don't longer log in into a server and edit configuration files. That is that was, people stopped doing that many years ago. What they do now is software gets infrastructure gets version control just as software, and is treated as code. And basically, the public cloud has enabled this over the last 10 years. And what this also means is that you can use the same practices you do for delivering the software, you can use them for the infrastructure, for provisioning a database, for example, or for configuring your network, etc. And the same team can be owning the entire piece of software end to end, from the development to the operations and the definition of the infrastructure. They are in total control of their own destiny. Now, sorry, I think this came out. There's a problem with this slide. Okay, so what is a DevOps engineer? So it is kind of fuzzy, okay, but you can imagine it as being there being two flavors of DevOps engineer. Okay, one would be a DevOps engineer that works in a product development team. Okay, so any engineer that is working on building products, okay, but owns their software end to end and is following all of the DevOps practices can think of themselves as a DevOps engineer. Okay, they are taking care of their operations, the infrastructure, their continuous delivery. They are doing continuous testing, etc., etc., etc. They are following the DevOps practices. That is a DevOps engineer. And there is another flavor, because in order to do all of these practices, you need tools, right? Yeah, here comes the second flavor of what a DevOps engineer can be, and it's the advent of what is being called recently a platform engineer or a platform team. Okay, so a platform engineer is a team that builds infrastructure and tools that make DevOps practices easy for the product teams on the left. And the teams that provide these platforms, and we will explain a little bit later what kind of things these platforms provide, follow DevOps practices themselves in delivering these tools and services. Okay, this is so these are DevOps engineers who are specialized in building the capabilities that enable DevOps practices for other parts of the company. Okay, so the part three is we're gonna talk about a little bit about what our teams do. Okay, I'm going to go first. So both Viktor and I work in teams that could be described as platform teams of platform engineers providing services for other teams in the rest of Adevinta that enable those teams to do practice DevOps practices more efficiently. Okay, so the team I'm part of is we developed something we call the Adevinta Common Platform. This is what you see here. This is what engineers in Adevinta see when they visit our internal website. Okay, and this is Adevinta's internal platform as a service. Okay, and so as you see, it's a service, and we develop it like a product. So in the end, it's not much different from what the product team does. There are 4 teams building this product. Okay, yeah, the Adevinta Common Platform, and they cover all of the above. So you sometime, let's say you apply for working at Adevinta, and you're interested in working for one of our teams, and we hire you and you get on board, you could be working in any of these things that I described here. Okay, so we have teams that are providing continuous integration services. So we have a service called Travis, which we operate internally, and we customize and we complete it with extra features that builds the software as it gets into the code base. Okay, we have some quality control software that we roll. We have an artifact management service where the software is stored after it's built. Okay, then we have some continuous delivery services. We have a couple of services that manage how the code that is built and tested in the continuous integration gets deployed into production. We also have a team that provides a managed Kubernetes runtime. So they operate Kubernetes clusters. They provide APIs for consuming those, for other teams to use those clusters, etc. Okay, they design how those engineers running software in those clusters can connect to their own networks and Amazon accounts, so they can connect to their databases, etc., etc. Okay, we also have tools for automating engineer developer workflows, and we have tools that provide instrumentation and let you observe how everything is working out from your process. We provide metrics about the engineering process itself to how your software is functioning in production. So you can send logs and send metrics, and you can see how, I don't know, how fast your software is working, on how many requests is it processing, how many errors are happening. So we provide services that allow you to track those things and enable product engineers to operate their software easily. Okay, and this is what we do. If you're interested, we would be super happy to hear from you. And now Viktor is going to tell you a little bit about the teams where he is working.
Okay, so I work in a team called Storage. The name is a bit misleading because we actually provide managed Kafka and Cassandra services. We're mostly focusing on Kafka these days. Kafka is used to transport data across different systems. What I want to highlight in this case, that our product is heavily built on top of Guillermo's offerings, but we are still a platform team, right? We are still building a platform for other engineers, but you can like put these layers of different platform teams on top of each other. All of our components are using infrastructure as a code idea. So everything is stored as a code. We are writing software to manage our software, right? Most of us are DevOps engineers, and our aim is to provide seamless integration for our customers. I believe that by providing reliable components, other engineers, both product and platform engineers, can stop having headaches about making sure that their own infrastructure runs in a proper way, but they can just use our services to offer. In storage is basically in the data and privacy tribe, and we have other teams as well. We have a lot of components actually to do A/B testing and other stuff. But I wanted to highlight this managed Kafka team where I work. And that's it from us, I believe.
All right.
Yes.
So now we are open to questions.
Yes.
So meanwhile, I fix the broken slide.
Yeah, probably when we moved them around, there was a mistake.
Okay, so we have one question.
Yeah.
How can you become a DevOps engineer? Where to start? Do you need skills in development, example, Python, Agile, previously, or you can start from zero? Like, for example, learning about cloud, AWS, Docker, Kubernetes, etc. So I think the answer depends on the skill set that you have right now, but I would say that regardless of your skill set, if you are interested, right, it should be possible to gradually gain all of the skills, right? I described at the beginning that DevOps is a set of practices, and that teams, the important thing about it is that teams today own a piece of software end to end, including all of these skills, right? So not everybody in each team covers all of the practices equally. So there are more people. Let me try to find the slide, okay, where I show the right here. So not everybody, you look at the screen, when you have a team of maybe 6, 7, 8 people, not everybody is going to be equally proficient on each of the practices, but as they're working together and owning the thing as a group, they get the opportunity to grow in each of the different practices, right? So you can start working. So let's say you are currently specialized in being a software engineer, okay? So you can get into a team and try to look for tasks and problems to fix or things to do in the team that are more on the right-hand side of this slide to get more proficiency with them. So you can decide to get involved in managing the infrastructure of the team, right? And that would mean that if you don't have cloud experience or Docker or Kubernetes, you will get the experience as part of the natural responsibilities of the team that where you fall, right? Now, it could be that today you are more proficient in the things that you mentioned at the bottom of your question. So cloud, AWS, Docker, Kubernetes. So probably you will be, when you join the team, you will be providing more value on the right-hand side, on the operating, et cetera, but you will have the opportunity to take on tasks that are on the software development side. So you will be able to learn them on that team, right? So as long as you can contribute to a team in one of these vertical areas, you will have the opportunity to expand towards the other. There is not a particular place to get started, okay? But let me just add that I would really recommend everybody when you start working in any kind of team to grow your skills to cover. So have a personal goal of growing your skills to cover the entire life cycle of the software, because it will make you a much more complete, versatile engineer in the future, and will let you choose your have much more control over your destiny and give you more opportunities in the future.
Yes, I 100% agree. I think having a full overview, looking at the full picture of how the software is developed, how the deployment is done, how the infrastructure is deployed, how you will run it in production, what the monitoring does, is essentially important to understand. But you don't have to be an expert in all of these steps, right? If you understand just the basics of it, that's a very good start.
Okay, and in this line, I wanted to ask you, and maybe you have half answered this question, but so what is the mindset you think that you would be looking for in a person joining your both teams? So maybe there are a couple of answers.
I can start. So what I would be looking at, I would like to see is an interest in like we have in my teams, there are people who are very much software engineers only. There are people who are more comfortable working on the infrastructure, or we try to mix it up. And there are people who try to cover everything. What I would value the most is an interest on covering everything. Not that you are able to cover everything today, but you have the interest, right? That would be very valuable.
Yeah, I think this is why both of us highlighted it. That usually you have in every team you have both of these people who are very infrastructure focused and very software development focused, right? But finding the right people who can take this overview of the full thing, these like T-shaped engineers, right? That's an important. So I think everybody is looking for these kind of people.
Great, thank you.
Any other questions? Yes.
Yes. First of all, thank you for making this very technical topic a bit easier to understand for all of us. It was really easy to go through it and understand the concepts. And you guys mentioned a lot of the failures that you've gone through over your career in the last few years and everything. What, in your opinion, is the most important piece of advice you could give to someone who's just starting out, whether it's in DevOps or maybe just starting out in their career?
And yeah, go ahead
go
if you have
No,
anything to say. It's a very hard question.
You go first.
Yeah. So for me, I will start with a story, and then I mentioned this before, but when I was younger, in after high school, starting university and working, I was very arrogant, and I thought I knew everything about. I mean, how hard can this be? This is just a computer and networking. And when other people didn't understand the problems, what I mentioned, and I had the solution already, and I had to explain. I didn't understand why they were not getting it right away, and then I faced some issues that I demonstrated, or I said a couple of times, right? And then I realized that the problem is that I don't know everything. So if you realize that you don't know everything, that's already the very first step. I mean, the very first step to achieve that, like, okay, maybe I will never know everything, but I can try to focus. So I think the best advice is to keep an open mind. When I was younger, I was reading a lot about different technologies. Even I was mostly focusing on infrastructure projects, but I was reading about software development. So it sounds like a cliche, but having an open mind and to try to understand other people's jobs is very important, because they might not be against you all the time. They just have a different understanding of IT in general, and they might not have the same knowledge that you have, right? This is what I would say.
I can add some more advice. So, if I had to, I would say I will leave 3 bits. Okay, one, don't feel like you are expected to know everything from the start and always get things right. Don't be afraid to ask questions, even as stupid as they may feel. And also, when you do know something and are good at something, be the person that is always willing to answer questions and help your teammates. That is a very important skill to have, and it's more important and valuable than people think, even later in their careers. Okay, and the other piece of advice is that in the first this is always important, but especially in the first years of your career, make sure that what you are doing really piques your interest and you feel passionate about it, because it will make you read about things when outside of your job, something that really captures your passion, because you are in a phase where you are going to soak up many experiences and knowledge. Okay, and it is, if you are working on something where you will read books about it when in your free time, it will really boost that knowledge soaking that you do in the first year of your career. Okay, then later things are important. What is important changes. Okay, but at the beginning you really want to the best way to really become an expert in something is to be passionate about it, right? So if you find that you work on you find yourself in a team that or in a company or in a place that where you feel like you're not really motivated, it feels like you could be doing something else and you wouldn't mind, don't be afraid to change. But if you find a team or a company where you feel like you're learning and you're really you feel motivated and engaged, grab that opportunity and stay there.
Yeah, I think this is a very good advice, to find something that you're passionate about, because then it it won't feel like working. It will be like a hobby.
This doesn't mean I don't want to make this feel like this doesn't mean, because sometimes you hear about companies that push people to work more hours than they should. This is not about that. It's about working on something, a topic that you get really grabs your interest and will push you to learn about it even beyond your regular. I mean, it will make you read books. It will make you talk to people. It will make you read blog posts, whatever. It will that will keep you engaged beyond what you're doing in your job. Okay, this is not about working more hours, not at all. Also, yeah, that's another advice. Somebody asks you to work 10 hours a day, run away.
Thank you very much. That is very practical and applicable advice that I think we can all start putting into our daily lives. And it's very important to really find something we're passionate about, or else working every single day would not be as fun or as challenging or as motivating. Definitely.
We have 3 more minutes for questions.
I think we did a very good job because no questions, right? or no DevOps engineers around, or nobody wants to become DevOps engineer.
Okay, so let me ask you one final question. It's not going to be that much DevOps related because I'm not that, I don't know that much about DevOps. It's been so good to know a bit more thanks to these talks. But so you've been talking about your experience, about the different places you've been working on. And actually, so we are doing this open day for people to join us, so to have a new experience. How do you think, and again, I'm talking about mindset, but what do you think the mindset would need to be when you are like in front of this big step? So in front of joining a new team, new company, new rules, new culture, maybe a new role?
What I will start, and then Guillermo can. I mean, I will say the easy things, and then Guillermo can be say the smart things, right? So for me, what I try to do when I join a new company, even after experience, I try to find the connection with the people. I know that in the early career program there are a lot of events that includes drinking beer and these kind of things. I totally recommend that you go there if you work in Adevinta or well anywhere else, because if you find the connection, the human connection with other people, then it's way easier to work together later. And I'm not saying that you should be friends and like have invite everybody with your family, but like if you have a personal connection, then it's way easier to work in later stages, and then you will be more inclined to, like, if there's a mistake or if there's a problem, it's easier to work together because you already know each other. This is an advice that someone told me a long time ago, and I try to follow it all the time, right? The second one is, if you don't understand something, ask questions. I mean, no one basically expects anybody to know everything, right? We don't know everything, and I wouldn't say that's normal. I mean this is normal. It's just like you need to be comfortable with asking questions. There is this like cliche sentence that there are no stupid questions, which is, I think, 90% true. If you like do a little bit of reading beforehand, and not just like asking everything that pops into your mind, but you prepare, you do your homework a little bit before, then like no one will tell you that, hey, this is a very bad question. you can go there like, hey, I didn't find this in the documentation. I didn't know like how to deploy this command. I don't know. And people will be very inclined to help you because you already have the human connection, one thing, and you did a little bit of the work of trying to understand it first before going there. I don't know if this helps or clarifies some stuff at least.
Totally. Yeah, I think it's really nice advice.